When people hear me, they usually think helicopters, big rotors, rugged bodies, battlefield workhorses, but 2025 flips that expectation on its head. The Mi-450 isn't a helicopter. It's not an aircraft at all. It's something built for speed, precision, and long-range dominance, a next-generation missile platform that's been quietly redefining modern strike technology. The Mi-450 represents a shift in design philosophy. Instead of brute force alone, this system focuses on intelligence, adaptability, and multi-role capability. It's engineered for environments where traditional systems struggle, like contested airspace, electronic warfare zones, and high-mobility battle scenarios. The goal isn't just to hit a target. The goal is to survive, think, adapt, and then strike. One of the first things that stands out is the aerodynamic design. The body is sleek, almost aircraft-like, with reduced radar signature shaping. The fuselage lines are smooth and blended, minimizing detection. This is not the bulky missile profile of the past. The Mi-450 looks like something from the next decade, because in many ways, it is. Speed is a core part of its identity. While exact figures remain classified, defense analysts place it in the high supersonic to possible hypersonic category depending on flight profile. That kind of velocity doesn't just reduce travel time, it compresses enemy reaction windows. Air defense systems that once had minutes to respond may now have seconds. But speed without control is useless. That's where the Mi-450's guidance system steps in. This missile reportedly uses a hybrid guidance package, a satellite navigation, inertial systems, and terminal seekers that can adjust mid-flight. That means if conditions change, weather, interference, or moving targets, the Mi-450 doesn't blindly follow its original path, it recalculates. Electronic warfare resistance is another key talking point. Modern battlefields are full of jamming systems trying to confuse incoming weapons. The Mi-450 is believed to use hardened communication links and onboard processing that allow it to operate even in GPS-denied environments. In simple terms, if someone tries to scramble its sense of direction, it still knows where it's going. Now let's talk versatility. The Mi-450 isn't designed for just one mission. Reports suggest modular payload configurations. That means it can be adapted for different operational roles, from hardened structure penetration to area denial roles. This modularity makes it less of a single-purpose tool and more of a flexible strike platform. Launch flexibility also matters. Unlike legacy missiles tied to one delivery system, the Mi-450 is believed to be compatible with multiple launch platforms, possibly ground vehicles, aircraft integration, and naval systems. That flexibility complicates enemy planning. You can't just watch one type of platform and feel safe. One of the biggest evolutions is in flight path control. Traditional missiles often follow predictable ballistic or cruise trajectories. The Mi-450 reportedly incorporates maneuverable flight phases, meaning it can alter altitude and direction during its run. This makes interception far more difficult because defensive systems can't rely on predictable arcs. Range is another strong point. While official numbers are unknown, the Mi-450 is described as a long-reach system that allows operators to engage targets from well outside traditional defensive envelopes. It shifts the balance, striking without entering the most dangerous zones. Materials technology plays a silent but important role. Advanced heat-resistant coatings and composite structures help the missile survive extreme speeds and thermal stress. At high velocity, air friction becomes a serious engineering challenge. The Mi-450's construction suggests careful attention to maintaining structural integrity under those conditions. Another interesting factor is onboard computing. Older systems depend heavily on external guidance updates. The Mi-450 appears to push more decision-making onto the missile itself. Faster processors allow quick air adjustments, improving accuracy and survivability. From a strategic perspective, weapons like the Mi-450 are about deterrence as much as use. their existence changes calculations. High-value assets must consider longer threat distances and shorter response times. Defense planning becomes more complex. Mobility of launch units is another rumored advantage. Ground launch systems may use rapid deploy platforms that can reposition quickly after firing. That shoot-and-move concept reduces vulnerability. Stealth characteristics don't make it invisible, but they buy time. Reduced radar cross-section means detection may occur later in the flight path. In high-speed engagements, even seconds matter. There's also speculation about networked operation. Future battlefields rely on systems sharing data. The Mi-450 could be designed to receive updates from external sensors, aircraft, drones, satellites, allowing real-time refinement. Environmental adaptability matters too. Extreme cold, heat, and electronic noise shouldn't degrade performance significantly. Modern systems are built to function in diverse climates. The psychological factor shouldn't be ignored. Advanced strike systems influence negotiations and defense posture even if never used. Comparisons with older generations show the shift clearly. Past missiles focused on either speed, range, or payload. The Mi-450 aims to blend all three with intelligence and survivability. Production methods likely use modern manufacturing, precision machining and composite fabrication. That improves consistency. Maintenance is another hidden evolution. Modular components could simplify servicing and upgrades. Future upgrades could involve better seekers or propulsion refinements. Modern platforms are built with growth potential. From a global standpoint, systems like this reflect an ongoing trend: more autonomy, more speed, more survivability. Cost versus capability always plays a role. Advanced tech is expensive, but performance gains may justify it. Testing programs would focus on accuracy, electronic resistance, and flight stability. Logistics chains also evolve. Secure storage, specialized handling. Training for operators shifts toward system management rather than manual calculation. As 2025 defense tech moves forward, the Mi-450 stands as an example of multi-domain design thinking. Whether viewed as a technological milestone or a strategic signal, it marks a new chapter in precision strike evolution. And in a world where reaction time keeps shrinking, systems like this define the next era. Fast, smart, adaptable, and built for the complexities of modern defense environments.